Right now, a city-sized chunk of ice and rock is hurtling towards the sun. This is Comet Ison. Astronomers around the world are tracking it as it blazes brighter.
We've amassed the most technologically advanced armada of spacecraft in human history.
It presents the opportunity of a lifetime.
I feel like a little kid when these sorts of things happen.
To answer mind-boggling questions.
This is going to give us a picture of this comet like we've never seen before.
And learn more about our world. What's more, Comet Ison could shine spectacularly in our skies.
Could be brighter than the full moon.
People are talking about comet of the century, even comet of the millennium. It's a really exciting time.
Now, all eyes are on Ison for what could be the comet of the century. September the 21st, 2012. As darkness falls, astronomers around the globe turn their telescopes skyward. For most, it's a routine night of observing. But they are about to discover something never seen before. An insignificantly small point of light. But a closer look reveals it's no ordinary star. It's a new comet. It lies over 900 million kilometers away, far out in the depths of the solar system. Comets are mysterious chunks of rock and ice, the size of cities. They usually lie beyond the realm of the planets. But occasionally, one can come close to the sun. When they do, they can grow spectacular tails, providing us with an incredible sight in the night sky. For astronomers, finding a new comet is an exciting event. But this comet is extraordinary. This is Ison.
Comet Ison is really important because we saw it first all the way out at 6 AU, 6 times farther from the sun than the Earth is.
Ison's unusual. It's much brighter than most comets, so it's visible from much further away.
Comet Ison being discovered so far out of the solar system means that it's obviously a very active object, and that naturally makes it more interesting right from the word go.
For many astronomers, Ison is a once-in-a-lifetime opportunity. Studying it could help answer some fundamental questions. Where do comets come from? What are they made of? And most importantly, how will it affect planet Earth?
1, 0.
Today, scientists have launched a huge coordinated effort to view Ison in unprecedented detail.
We've amassed what is the single largest and most technologically advanced armada of spacecraft in human history, and we are turning those spacecraft to look at the comet over the next few months.
And from Earth, it has the potential to blaze in our night skies.
Ison could be a spectacular naked-eye comet. Could be brighter than the full moon.
People are talking about comet of the century, even comet of the millennium. It's a really exciting time.
Today, Ison's imminent arrival is awaited with eager anticipation. But comets haven't always been greeted with such enthusiasm. Turn back the clock just a few hundred years, and the reaction is very different. Throughout history, the sudden appearance of comets sent people running for cover. For astronomer Francisco Diego, their terrifying accounts give an insight into how our ancestors viewed the heavens.
In the old times, people realized that the sky is moving in a very orderly way, and they were developing calendars and ways of predicting all these motions of stars and planets and the sun and the moon. But suddenly, out of nowhere, we have these apparitions. The comets will come very fast against all these orderly motions that were so predictable. It must have been terrifying.
Even men of science, the astronomers of the time, thought comets were the harbingers of doom.
There is a quote by an astronomer in the 1600s. As often as any comet or blazing star appears in the world, we may assuredly pronounce to the inhabitants of the earth much sorrow and affliction, unusual storms and tempests, corrupted and infectious air, plague and famine, all tending to the mortality and destruction of humanity. That is amazing.
It's easy to dismiss our ancestors' fears. But today, scientists know a comet could pose a real threat to humanity. February the 15th, 2013. The world gets a spectacular reminder of how vulnerable we are to impacts from space. A chunk of rock over 15 meters across hurtles towards the Earth near the Russian city of Chelyabinsk. The meteorite itself hurts no one as it disintegrates in the atmosphere. But minutes later, the powerful shockwave it creates shatters windows, injuring over 1,000 people.
The Chelyabinsk meteorite was a small object, but even being such a small object, it caused a lot of damage.
At around 5 kilometers across, Ison is hundreds of times larger than the Chelyabinsk meteorite. Something this large slamming into the Earth would do much more than shatter windows. It could be devastating. Our first line of defense against a comet impact is Gareth Williams at the Minor Planets Center. Gareth's job is to calculate where Ison is heading and how close it will come to Earth.
The Minor Planet Center is responsible for keeping track of asteroids, comets and natural satellites, particularly those that can come very close to us or even hit us. We want to be aware if and when that is going to happen.
With the help of powerful computers, Gareth starts calculating the comet's orbit. But just days after its discovery, that's easier said than done.
The problem with any object for which you've only got observations over a course of an hour, it's very hard to get a general orbit, to say with certainty this is the orbit.
Gareth turns to the global community of astronomers for more observations of ISON. But after hours of number crunching, he's still not sure whether the comet will strike us or not.
Even 3 days after discovery, I could easily fit more than 600 different, wildly different orbits.
It's hardly a precise answer. What's alarming is that some of the orbits bring ISON dangerously close to Earth. But Gareth has a final plan he hopes will help refine his calculations.
We can look in the past. We may have received observations from an observer who didn't realize that he had an interesting object.
The computers store a back catalogue of thousands of celestial objects. It's just possible that ISON might have been seen and logged before. This could be the breakthrough Gareth's looking for.
We used a computer program that takes those 600 orbits and compares them to all the unidentified observations, trying to saying, does this observation fit this orbit?
Gareth's in luck. Comet ISON was logged twice before. Now he can finally narrow down the 600 orbits to one.
One of the orbits of ISON produces 2 matches amongst the unidentified observations, and it's a really interesting orbit.
Gareth's calculations reveal ISON's orbit takes it almost 65 million kilometers from Earth. So we're spared from Armageddon. This time. But ISON might be on a path to its own destruction. On November the 28th, 2013, it will hurtle past one of the harshest environments in the solar system. The Sun. The countdown to its sun-grazing encounter has begun. Comet ISON is driving headlong towards the Sun. For astronomer Carl Battams, its newly calculated orbit is key to understanding what the future holds in store for the comet.
The predicted orbit for ISON means that it's a sun-grazing comet, and as the name implies, that means that this little ball of ice and rock is going to go flying right through the solar atmosphere, and it's almost literally going to graze the surface of the Sun.
ISON will skim incredibly close over the Sun's surface.
And this certainly has some very interesting and very exciting consequences.
First, there's the Sun's searing heat.
The comet is going to be experiencing incredible amounts of solar radiation.
Then there's its immense gravitational pull.
When something like a comet is very close to the Sun, it actually gets elongated, it gets stretched.
Finally, it'll be traveling at an incredible speed. Fast enough to fly from New York to LA in under 20 seconds.
We've got this extreme environment that this tiny, delicate little ball of ice is going to be flying through.
Passing so perilously close to the Sun could destroy ISON. But it might also provide a spectacular sight. Seen from Earth, ISON could appear as the comet of the century in our skies. January 2013. ISON is around 800 million kilometers from the Sun. Scientists have discovered it's on course for an incredibly close encounter. But for astronomer Kerry Lisk, ISON's orbit helps solve another puzzle: where the comet came from.
In front of me is a model of the solar system, and in it you can see that there are thousands of known comets. If we look at the comets, most of the comets seem to be going in the plane of the solar system, moving the same way that the planets do around the Sun, almost like grooves in a record. But ISON is not that kind of comet. ISON is coming from a very different orbit that is not flat at all with respect to the solar system. It's coming from very far north at a very steep angle to the flat plane of the solar system. We know that ISON is a different kind of comet.
Its orbit reveals it has a unique path. Some comets orbit the Sun time and time again. But ISON will swing by just once before heading outwards, never to return.
So to see where these comets come from, we have to step way, way back. We have to really take a big view of the solar system. ISON comes from much, much farther away, 10 to 100 to 1,000 times farther away, in a region that extends halfway to the next star. It's what we call the Oort cloud. It's a giant sphere of comets that extends halfway to the next star around the Sun.
The Oort cloud is thought to contain up to 2 trillion icy comets. But where did comets like ISON come from? Astronomers like Amy Mainzer think the answer lies with the formation of the planets.
When the solar system first formed about 4.5 billion years ago, it started off as a cloud of gas and dust that collapsed to form a disk. And you can imagine just like this sugar, all these little grains of dust circled throughout the solar system, spread in roughly a disk shape around the forming Sun, which you might imagine to be here in the middle of the table. Now, eventually, under the influence of gravity, some of these little grains of dust are going to start to stick together, some of them starting to form little lumps, like these right here. Now, some of the larger of these lumps are going to stick together to form the planets.
Most of these chunks smashed together, but some were flung outwards to form the Oort cloud.
And these can scatter really violently into the outer parts of the solar system, where they're going to stay in the deep freeze of outer space for billions of years in some cases. And one of these little chunks is Comet ISON.
It's an amazing revelation. ISON is a pristine piece of ice and rock left over from the formation of the solar system. And contained within this time capsule lie clues to how our planet evolved. ISON is speeding ever closer towards the Sun, pulled in by its immense gravity. Astronomers have learned it's left over from the formation of the planets. But what sent it tumbling in from the very edge of the solar system?
So if we take a step back from the Oort cloud surrounding our Sun, we see that our solar system is just one star among hundreds of billions of stars that make up this giant collection that we call the Milky Way galaxy.
Galaxies aren't static. Over millions of years, they rotate.
If we speed up time and we look at this giant pinwheel we call the Milky Way galaxy, we realize that all the stars in it rotate around a common center, the same way that the planets in our solar system rotate around the Sun. And every now and then, as this Milky Way galaxy is rotating, we pass by another star. And that star comes close enough to actually perturb the comets in our Oort cloud.
The extraordinary conclusion is the gravity of another star pushed ISON out of the Oort cloud.
Millions of years ago, close to the dawn of man, Ison was perturbed by a passing star and started falling in towards the inner solar system, towards the sun, so we could see it today.
It's an incredible thought. We're able to witness the final stage of Ison's inward journey. A journey that began when humans first walked the Earth. April 10th, 2013. Comet Ison is moving closer. It now lies within the orbit of Jupiter. It's close enough for Bonnie Meinke and the team at the Space Telescope Science Institute to capture detailed images using the Hubble Space Telescope orbiting above the Earth.
Hubble's designed to look at small things, distant things, faint things, and that's what Comet Ison is at this point. It's just a small hunk of ice out there in the far solar system.
These images of Ison reveal something intriguing.
What we're seeing with Hubble is that Comet Ison is developing a coma, and that's a huge layer, kind of like an atmosphere around the nucleus of the comet. It's full of gases, and they're raging like a snowstorm around this nucleus.
Ison is erupting clouds of gas in a process called sublimation.
I'm going to show you how that works with some dry ice and some water. So we have our dry ice in a bowl, our cryo gloves for safety. We can put those on, pick up a small piece of dry ice, and we'll place that in the water.
As the dry ice hits the warmer water, a chemical reaction occurs. The ice turns straight from a solid into carbon dioxide gas, causing it to fizz violently. Amazingly, Comet Ison is undergoing the same reaction.
This is exactly what happens with comets as they come into the inner solar system and warm up as they get closer to the sun. All of that solid ice begins to sublimate and form a coma.
As it continues to heat up, the dry ice fizzes even more.
So you can see that the chunk of ice is now beginning to spin. And that's because gas is coming off in different directions.
But what's exciting about Ison is just how much gas its icy nucleus is releasing.
Hubble is showing us that the whole coma is about the size of the United States. But if you move all that away, you can see that the nucleus is tiny, only about the size of Manhattan. That tells us that this comet is raging.
Even in the freezing depths of space, Ison is violently reacting to the heat of the sun. Most comets out here are usually inactive.
So if Comet Ison at this point is able to create such a huge coma out of a very tiny nucleus, this bodes well for its future. Hopefully it'll continue to get brighter and brighter.
We are able to see Ison because of sunlight reflected from gases and dust that make up its coma. But as it continues to warm up, something incredible happens. Its gases start to glow with a light of their own. This gives astronomers a unique opportunity to see what Ison is made of. It's similar to what we see with everyday street signs. Their tubes are filled with gases like neon. Electricity passing through the tube energizes the gas, causing it to glow brightly.
So here I have a lamp that is filled with gas that I'm going to make glow when I click the switch on. and it is emitting light, the same way that gases in a comet's coma emit light. And it looks to you like it's a reddish-orange glow.
In fact, the orange light emitted is made of a number of different colors mixed together.
When I hold this film up in front of it, you're going to see that light split into many, many, many different lines. Mostly red and orange, a little bit of green. The exciting, fascinating thing is that I can tell you that this must be neon atoms in that tube.
Every gas produces its own unique pattern of lines when it glows. These are called spectra. Like a barcode in a supermarket, if you can identify the spectra, you can identify which gases are glowing. And that's incredibly helpful when studying ISON.
So if I know what this is doing in the lab, and then I go and I look at a comet and I see these 4 lines, I know that there's neon in the comet. And seeing the glow of the atoms and the molecules in its coma, we can tell you what's there, and we can tell you how much is there.
It's a powerful technique called spectroscopy. And over the coming months, it will provide astronomers with a detailed breakdown of ISON's chemical composition. Spectroscopy has allowed scientists like Lewis Dartnell to build up a chemical profile of comets, and it's revealed some startling results.
What we've discovered more recently, there's a lot of other very intriguing chemistry, a lot of very exciting molecules that are mixed into their recipe alongside that ice.
ISON is a time capsule. Locked in it is the chemistry that existed when our solar system and Earth formed.
What really excites me personally about these comets is what they can teach us about the kind of primordial chemistry that would have been around in the early solar system. And ISON in particular is unique because it's falling into the inner solar system for the first time.
The chemical information scientists glean from ISON could provide answers to one of the greatest mysteries of our planet. Comets have long been mysterious objects. But as science historian Patricia Farah knows, that ghostly apparitions helped prove one of the most important scientific theories of all time. The evidence lies in a book over 300 years old at Clare College at the University of Cambridge in England.
This book is Isaac Newton's Principia, and it's the single most important book in the history of science. It's in this book that he describes gravity as a force that holds the universe together.
It's often said Newton hit upon his theory of gravity while watching an apple fall from a tree. But the truth is very different.
Towards the end of 1680, a new comet appeared in the sky, and many people were absolutely terrified. But for Newton, this was a new opportunity. It was a challenge to try and work out what was happening.
Newton was thinking how gravity might explain the elliptical orbits of the planets around the Sun. But the movement of comets remained mysterious. Could they also be explained by gravity? Newton sets about measuring the 1680 comet as it slowly moves across the sky until it's lost in the glare of the Sun.
He's showing the time the comet appears, where it is with respect to the Sun, the longitude and the latitude of the comet.
What he sees next intrigues him more.
Then, a few months later, beginning of 1681, there's another comet in the sky. So Newton tracks that, and it's on the other side of the sun. So Newton starts thinking, well, is it really another comet? Or has this comet somehow come back again? So this is a diagram that Newton drew to explain the observations of the comet that he'd made. And there it is, observations in November. Then it goes round the back of the sun, reappears in December, and here it is coming up to January 1681 and February, and off it goes.
Newton realizes something astonishing. The comets of 1680 and 1681 are in fact the same comet. One that's followed an elliptical path around the sun. From his observations, Newton makes a bold prediction. Comets, like the planets, must be controlled by the same invisible force: gravity. But it takes another English astronomer, Edmund Halley, to appreciate the significance of Newton's theory. Halley realizes, if Newton's right, maybe other comets have circled the sun and appeared in the sky more than once.
So Halley went one step further. He started collecting historical records of comets that appeared in the past. And what he noticed was that several of them had the same sort of pattern.
In particular, 3 comets seen in 1531, 1607, and 1682. Halley then makes the biggest bet in the history of astronomy. Not only does he suggest they're the same comet, reappearing every 75 years or so, but he boldly predicts the comet will return again in 1758. As the year approaches, the excitement builds.
If I were an astronomer at that time, I would have looked at the sky every night and I would have thought, am I going to be the first person to see this comet? Is it really coming back?
On Christmas Day, 1758, Halley's comet returns. Its predicted appearance spectacularly vindicates Newton's theory of gravity.
He might well have watched apples fall from a tree, but what was much more significant is that he watched a comet flying through the sky in 1680 and 1681. And it was that comet that inspired him to formulate the great mathematical law of gravity that ties the universe together.
Sadly, neither Newton nor Halley lived to witness the returning comet. But their interest in these fiery apparitions changes the way we understand the universe forever.
From then on, it was absolutely impossible for astrologers to say that the appearance of a comet heralds some incredibly significant disaster. From then on, the comets were part of the universe. They'd been taken in within the clockwork mechanism of nature.
Astronomers have learned a great deal more about comets since Newton and Halley. They come from beyond the realm of the planets. They formed billions of years ago during the formation of the solar system. And their icy centers carry a cocktail of chemicals. Now, ISON heralds an exciting new chapter in our understanding of comets. But despite all we've learned, comets can still cast dark spells. Spring, 1997. The Earth is treated to a spectacular comet. One of the brightest in many years. Hale-Bopp.
It came very slowly because it was quite far away from the sun, and it moved very slowly and it stayed for weeks actually. You could see it all the time.
But for a group of people in San Diego, Hale-Bopp triggers a sinister series of events.
If I would title this tape, it would be Last Chance to Evacuate Planet Earth Before It Is Recycled.
The Heaven's Gate cult think Hale-Bopp signals the end of the Earth. To escape, the members believe they must board a spacecraft concealed behind the comet's tail. But it requires a grisly sacrifice. The members of the cult commit mass suicide. In all, 39 bodies are discovered.
So I find amazing to realize that people still got this reaction to these apparitions of comets in the sky.
October the 2nd, 2013. Just over a year after its discovery, ISON is now within 350 million kilometers of the Sun. Now the comet is close enough for astronomers on Earth to get their first detailed look at its composition. Astronomer Adam McKay is traveling to an observatory in the mountains of New Mexico on his way to observe Comet ISON.
So we're heading up to Apache Point Observatory to use the 3.5-meter telescope there to obtain spectra of Comet ISON.
Perched high in the Sacramento Mountains, Apache Point is treated to some of the clearest skies in the United States.
Every observation for a comet is unique. It's changing its distance from the Sun, changing distance from the Earth, and that really makes every observation very important.
Adam's one of the first astronomers to use spectroscopy with an Earth-based telescope to observe ISON's coma, the gaseous atmosphere surrounding its icy nucleus.
One of the things we're really hoping to measure from the spectra we get tonight is the water production rate of Comet ISON.
Over the next few hours, he tracks ISON, analyzing its glowing gases.
So here's a spectrum of Comet ISON that we were just able to obtain. Basically, the actual spectrum is all these bright rows that you see here going across.
ISON's spectra might not look like much, but with a trained eye, Adam makes an important discovery.
One of the things we're really interested in is this bright spot right here. And that corresponds to atomic oxygen that is present in the comet.
Oxygen is one of the two elements making up water. And Adam's discovery suggests the nucleus of ISON is gushing water vapor as it continues to warm up.
This is one of the very first detections of water in this comet.
It means that when ISON formed, water must have been present.
This is material that, as the solar system formed 4.6 billion years ago, gets incorporated into comets and has basically been locked in a time capsule ever since.
The discovery that ISON contains water adds weight to an incredible theory that might answer one of the biggest mysteries about our own planet.
There's a lot of water in the world today, but what we think is that the early Earth was created as quite a dry world. So the question is, where did that water come from?
The answer may lie with comets like Ison.
The chances of the Earth being hit by a comet today are, thankfully, quite slim. But it wasn't always like that. And billions of years ago, in the early solar system, when our world had first formed, the rate of comets pummeling down onto the surface of the inner planets would have been much, much higher.
The evidence for these cataclysmic collisions is closer than you think. The moon's ancient surface preserves the scars of craters and vast impact basins. Many formed around 4 billion years ago, when comet impacts were far more frequent.
The moon is like a pristine record of what would have been happening back on the Earth at the same time, but the dynamic surface of our world has erased any evidence that period once happened.
The Earth was also subjected to this intense bombardment, thought to have lasted for millions of years. Astronomers calculate an average-sized comet carries millions of tons of water. Many thousands of them, impacting Earth, might have delivered the oceans that cover our world today. But spectroscopy reveals something even more intriguing. Comets carry molecules necessary for life.
What's even more incredible is these comets are full, we now realize, of organic compounds, the building blocks of life on Earth. Not only would they have been delivering water to fill our oceans and give the wet stuff for life to get started in, but they would have been helping build up this reservoir of the building blocks for life as well.
It's only a theory, but it's a profound thought. We may owe our existence to comets like Ison. November 19th, 2013. Ison is about to experience the most perilous part of its 4.5 billion year life. Streaking past Mercury, it's just days away from its sun-grazing encounter.
Sun-grazing comets like to live dangerously, and it's an open question as to whether or not something this cold and icy can survive a passage by the sun.
The next week will be make or break for the comet. Will it be destroyed by the ferocity of the sun, or will it survive? The immense power of our sun is a force to be reckoned with. Solar scientist Alex Young at NASA's Goddard Space Flight Center knows Ison is in for the ride of its life.
These images are showing us the surface of the sun and its outer atmosphere called the corona in extreme ultraviolet light.
The corona is heated to over 2 million degrees and twisted by super strong magnetic fields. Comets venture here at their peril.
You can see here these lines which are tracing out magnetic fields. This is what Ison will be passing through.
The magnetic fields can twist and violently snap, causing explosive solar flares.
You see these bright flashes here? These are solar flares that are releasing huge amounts of energy.
As ISON passes around the sun, it will feel the full force of the solar maelstrom.
Standing on the surface of ISON, you would be feeling all of this material that's boiling away, blasting out into space. You would be feeling the intense radiation from the sun, the unbelievable gravitational forces pulling underneath you, magnetic fields slamming into you, just an incredibly harsh and hostile environment.
November the 28th, 2013. This will be D-Day for Comet ISON. Its encounter with the sun. And for our scientists, it's the day they'll learn ISON's fate. They've narrowed it down to a number of likely scenarios.
So there are several things that could happen to Comet ISON on its passage in towards the sun.
One scenario deals with the intense solar radiation.
This is a big risk for a comet, because if those ices, if too many of those get vaporized away, the comet is just going to fall apart. It's going to dissipate into its constituent parts and just fade away out of sight.
If this happens, we'll lose sight of ISON forever. Another scenario deals with the sun's immense gravity.
The gravitational pull of the sun is going to stretch the comet, and if the comet is just not structurally strong enough, it could just get completely ripped apart.
That's what happened to comet Shoemaker-Levy 9 in 1994, when it strayed too close to Jupiter. The giant planet's gravity tore it into 21 fragments. If the sun does the same to ISON, we could be treated to a spectacular sight on Earth. But there is hope for ISON.
So the final scenario for Comet ISON is that it actually survives. It flies past the sun, it goes through the million-degree solar corona, and it comes back out the other side in one piece.
Which means we might get to see ISON again, blazing in our skies in December.
Any one of these scenarios is possible, and it may be we get a combination of a couple of them.
The wait is almost over. Just days from now, ISON's fate will be determined. Then we'll all know the final chapter in the life of this incredible comet.
So all eyes are on ISON right now. Everybody's watching. We really want to know what's going to happen to this comet.
I feel like a little kid when these sorts of things happen.
I have a feeling it's going to break up. But when a comet breaks up, it's still spectacular.
If you're able to see this comet and see it in the sky, that's a memory that will live with you forever.
I want huge flare-ups. I want it to be bright and brilliant. If it's going to go out, I really want it to